Hello, everybody, and welcome to today's use cases team for ODTN. Thanks for joining. The first item of the agenda, I'm pleased to announce to everybody that we have an accepted demo at ECOC, the European conference on resiliency and failover for ODTN. What that means is that the demo will be comprised of two parts. The first one is resiliency in data plane, where we will deploy ONOS in a 3-node instance, kill an instance, and still see that we can deploy and delete connectivity services across the optical domain. That's the first step. The second step will be actually issuing a simulated fiber cut, where we bring down a port either on the ROADM or the transponder or the OLS, depending on the deployment that we decide to go for, and that ONOS will reroute the traffic and reissue a connectivity service request and wavelength tuning and power tuning for keeping the traffic still flowing within the network. So that's the two steps of the invited optical demo that was accepted at ECOC. So we're going to have that one there, and we're probably also going to be present at the tip booth with a physical demo of Cassini plus either an open line system or a set of Lumentum ROADMs, which probably will be the case. The same demo, I think, will be. We're going to do it at ONF Connect. I'm actually considering doing the demo for NF Connect and then replicating it at ECOC and then TIP Summit. What I would like to have in the demo is also the power configuration, of which we were going to talk about later. I think that once we establish the workflow and the different components enable us to have power control, it should be fairly straightforward to be able to do that level of fine-grained control within transponders and open system or ROADM. The other one that I've been talking with Vittorio from Polytechnic of Turin. We actually have set up a meeting for tomorrow to discuss this more, and also on the 17th of April, I'm going to travel to Turin to see the GMPY team in order for them to integrate with ONOS and probably submit a demo at ECOC too, and also maybe show this integration to ONF Connect if that is a feasible time frame. So again, for anybody who wants to learn more about GMPY, I placed a few links in the document so you guys can go ahead and learn. I would like to thank Kevin for organizing the meeting tomorrow with the GMPY group. From Juniper and from Polytechnic of Turin. I think the first order of business that we're going to talk about tomorrow is exactly a few things, two things mainly. One is what type of parameters GMPY needs in order for it to be used, for it to do his path computation. And that is because I would need to understand if these parameters are obtainable by ONOS to the OpenConfig and TAPI interfaces that we have towards the devices, and if those parameters are exposable through a TAPI northbound interface. So that's the first element. The second element is how hard would it be to extend GMPY with the TAPI interface. So these are the kind of the steps that we're going to go for the GMPY integration. And that would basically extract the path computation from ONOS. That's kind of the idea. I would like to do the path computation and calculation outside within GMPY if possible, and have a very minimal one in ONOS in case you do not deploy GMPY as a sidecar. Okay, I would skip the Flowroot programmable update because I think Alessio is going to join. It's just that he's in another meeting and he might join us a little bit later, and he has some great slides that he wants to present. What I want to discuss today is the feedback that I received from the ADVA folks on the workflow for the power configuration. So I have exchanged an email with Conrad and others from ADVA, and the outcome of that discussion is two possible workflows that they have suggested to be possible within our project. The first one is that we need to retrieve the target power from the transponder that the transponder wants to receive. Then we need to request a path computation to the open line system uh, with that given receiving power on the transponder, meaning an output power on this port. We need to request that to the OLS, and if the OLS can give such path to us, we can go forward. If not, we probably need to retune or ask again the transponder if it can lower the target power or put a higher target power, probably lower. Then we need to compute the power for the sending transponder, for the transmitting transponder, and then configure this power and the wavelength on these two transponders. And then, since at that point the light is activated, we need to actually request the connectivity service establishment to the open line system with those constraints that we talked about. Is this something that is reasonable from everybody's perspective? I think is okay, but I would like to hear everybody's opinion.
In my opinion, it seems reasonable. I think it's okay.
I agree with that.
Okay. The only question I have is, at least for the TAPI experts, I think we can. I don't think we have people from TAPI today, but I think we can ask a connectivity service with a specific power on the service interface point, but I'm not 100% sure.
Starting from the new version, yes. I mean,
Okay, perfect. So
the recent upgrade of the TAPI 2.2, at least for the first release candidate, allows you to select which is the target output power that need to be sent out from the OLS in every port. And yeah, that can be requested to the connectivity service.
okay, perfect. That's great.
The other question I had was, since you're getting the receive power target from the transponder on the right hand side, and you're sending from the left, do we also need, in order to be able to set things later in this flow, what the available setting range for the TX is as well? Because in order to do the path compute, you'll have to know what you can launch in at.
Indeed, that's a very good point. Thanks for bringing it up, Kevin. Transmitting capabilities on TX transponder. Yes, indeed we should, because if the two have a mismatch, we probably ought not to do anything and just break it. Like if the receiving power is something that the transmitting transponder cannot issue, which is probably a situation which will not happen if the two transponders are bookended. But while we are at it, I think we might as well get it from the transmitting transponder too.
Yeah, and I think that the OLS in the middle may be able to transform the power levels to be appropriate. But for example, if we run the first case in 2 and we don't get enough power at the receiver, one of the options that we potentially have is to increase the launch power at the head end.
Oh, yes, indeed. Yeah. Okay. So I think we will concentrate on this workflow. As I stated in the past, we do have already a power configuration class in ONOS, and I asked Buyan from ONF to start taking a look at it for the transponders. And what that does is just tunes the power on a specific port. And now I have to see if either we use it in the flow root programmable or exactly how to do it. We just need to figure it out, like in detail. But we have that class, and so we have this power config behavior that enables us to tune through OpenConfig. I started with the OpenConfig, and then we can go and check the OLS workflow. Buyan, any comments on that?
I think no.
Okay. Thanks. We will follow up on it as soon as since we have set up the workflow. I think we can go forward with the implementation as soon as we can, and as soon as we have some time. And I'm gonna work with the people from ADVA to properly test this workflow with their OLS. Questions? The second one that they proposed is a little bit more advanced with a full OSNR computation. And that is basically, so I need to augment this with the suggestion from Kevin too.
Yeah, and I would also add to that, Andrea, that in this case, it's not just the TX power range, but it's also the TX starting OSNR as well.
Yes. Yes. So this requires augmentation for TAPI for the OSNR.
Yeah.
Which is something that we will have in discussion with the TAPI group. I'm also we will start the discussion with the TAPI group based on this use case, and we will pull in the people from ADVA depending on the need of this specific use case. But the rest of it is pretty much the same, except that there is a step more in the request to the OLS that it could fail for the OSNR, and at that point, if we don't have if the path computation fail for OSNR reasons, we cannot recover. At least that's what Conrad asks. So we need to have a fully new path set up if the failure for a given path that we pick is due to OSNR.
Just a question on that. In terms of multi-rate transceivers, clearly if we do the setup of the mode of the transceiver first, then I think it's okay to follow that logic and fail and then go back, and outside of this then change the mode if that's an option. Is that how you envisage it? For example, switching between QPSK and 8 or 16 QAM, because that will change the required OSNR for the receiver.
Yes, that is definitely an option. I think this could be an option. Yes, I think that this requires a little bit more discussion, and I would like the ADVA guys to be in the call before we go down this route. But we're gonna start with this, and then this is just gonna be an add-on to the power one we have. Make sense?
Yeah, that makes sense.
I just wanted to raise one question here. From the path computation perspective, even in the first case, like just for the power setup, do you need to send to the OLS controller the exact target power that is going to receive and that it needs to send out, or is enough to let's say a range like minimum and maximum input and output power that is expected and intended to be received and transmitted?
You mean in step two,
Yeah.
which holds true also here.
Exactly. I mean, there you say request path computation to OLS with transponder received target power. Here you could basically have like minimum target, which is okay, but in the sense, I mean, in the part of the transmission, you probably have a minimum and maximum power range that the transmitter is able to send, and then uh, what it is valuable for the path computation in the OLS, the exact value that you are going to configure to be sent by the transponder, or the range that is able to transmit.
Okay.
In the sense, is an output of the path computation the target output power that need to be configured in the transponder, or you are going to set up this target power in the request, and the path and the OLS has no degree of flexibility on choosing which is the better transmission power that need to be received.
Yeah, I mean, the way I see that, I think that's an important question. The way I see it is that you would expect to set the power of the transponder at the head end, but I think you're right that we would expect to see a range of powers at the receive end, based at least on the uncertainty of the path.
I also wanted to mention this because right now in TAPI what it is allowed to configure. We are still on time to change that, but it's just the range. I mean, you have the parameter of minimum and maximum supportable transmission power or something similar. So when you make the request into the OLS controller, what you will send there is which is the minimum and the maximum transmission power that can be configured in the transponder transmission. But maybe it will be a good idea maybe to propose a little change into the model to allow also the exact value or target value in order to have both options.
I mean, to me, the workflow does not change that much. Actually, if the OLS is capable of accepting a range, it's actually more flexible, because what you say is that I'm fine with this band, and that the OLS has more choice on the path it can take inside itself. So I think we should actually go for this solution, and let's leave it as a question, and then on next week's call we can discuss with the people from ADVA if this is okay.
Just to complete this, then in the third point, when you say compute output power for transponder, I guess that this is calculated by the OLS controller?
Well, no. I mean, in the sense that we. It's a good question.
I see that more as an input. So I see that more in stage two. When you're requesting the path computation from the OLS, you will try with a particular target TX power and see whether you can land your receive power within the range specified in two, if that makes sense. And then if it fails, one of the options you have, or maybe one of the options you have, is to adjust the transmitter power.
Okay, that's fine. Then so if I understand correctly, we retrieve the receiving power, we retrieve the transmitting power capabilities, and then we ask the OLS, can you give us anything which is in this range of transmission and receiving.
Well, there are two ways I can see it being done. The first one is for ONOS to say, given the range of the transmitter's capability, I am going to, for example, set to the highest power and then ask the OLS whether it can deliver me a receive power within the range that I want. The other option is to do exactly as you said, which is to provide from ONOS to the OLS controller a range of transmitter and receiver powers and say, can you find me a solution with these two bookended conditions?
Yeah, okay. Okay, let's do
where
this.
do you want most of the intelligence, in ONOS or in the OLS controller?
I think that it depends on what they already have on the OLS controller. If they already have such an implementation in the OLS controller, I'd leave it to them to do it. If they don't have it, I'll bring it into ONOS.
Okay. So I think maybe you start with this is the range of transmits that I can use. This is the range of receives I need to fall within. Can you find me a solution? And then if we need to bring intelligence back into the ONOS layer, then that would be an easier step to come back from that.
Yes. I
Okay, that sounds
would
good.
say so.
I agree on this, and then just the comment is that we need to propose in TAPI a modification in order to allow an exact target output power in the request, both to the path computation and both to the provisioning of the connectivity service.
Yeah, I think that would be useful to be able to set the transmitter to a particular output power. So I think that's a good idea.
That's a thing, and another thing that I'm just thinking now, if potentially we would like to do the other approach on which you specify the range in the path computation, the output, the answer from the OLS controller path computation should be a target output power. So this also should be included in TAPI at a certain point if we wanted to have this flexibility. But anyway,
Exactly.
maybe we can go for the first one and just propose the first.
Yeah, I think you made a very important point there that needs to be added here. So maybe 3 becomes 2C, which is if the path computation succeeds, we need to set the transmitter power with the value returned from the OLS.
Yes.
Yeah.
Yes. Okay. Yeah. Let's talk with the ADVA guys about this and see if this is supported within their controller. I think it's a pretty straightforward ask and should be supported fairly easily. I know that they are implementing it, so I think it's okay for them to still work on it. So I think this is pretty good. Any other questions? Okay.
Just a comment, just reading ahead. You've actually got set the wavelength and power on the transponder in comment 4, so we could just combine 3 and 4. Thank you.
Thanks, Kevin. Okay. Yeah, that was all I had on the power. I think it's a pretty good workflow, and we just need to figure out the capabilities and the exact details on the range and the exact target within the ADVA system. So let's talk with them as soon as next week's call. I'll make sure to send them the recording of this piece of the meeting, so that they can be up to speed with the discussion we had. Okay, so thanks for that. I saw that Alessio joined. So let me bring up his slides, and he can talk about them.
Hello, Andrea. Can you hear me?
Yes, perfectly fine.
Okay, thank you. Okay, so I just prepared these a few slides to provide an overview of our work that we did for the driver of the terminal devices using the OpenConfig model. In the first slide, Andrea, are you moving the slides?
I am.
Okay. Here there is only the link to the Gerrit patch, and I listed the main files that we have modified that essentially are the device discovery, the flow rule programmable, and these side file that we have created, that is the terminal device flow rule, that is essentially used to parse the flow rules that arise from the core to the driver. Then in this patch, I have also included some smaller modification to the compilers of both the optical circuit intent and the optical connectivity intents, and some small modification to this optical REST application that enable push, get, and delete of optical intent from the REST interface. In the next slide, you see an example of the flow rules that are generated. And Andrea, can you move?
Yeah, just give it a second. It's not that fast.
Here is I just did some screenshots from an instance of ONOS that we have working in our lab using this OpenConfig model for the transponders and for some roads that we have in the lab. We are using a model that is not still compliant with the open roadmap, but we are working in that direction. So here you see that here we have requested a bidirectional intent between two line ports. So in this case, only an optical connectivity intent is generated and compiled by the core. And you see in the intent list that there is only this optical connectivity intent established. And then there are the flow rules. The first, the second screenshot is about the flow rules installed at the transponder. We have the two direction because the intent is bidirectional. The first row is the ingress direction, where the flow rule includes in the selector only the input port, and in the treatment essentially the input port and the OCH signal specifying the frequency and the central frequency and the width of the channel. And then we have the egress direction that is the opposite essentially, where in the selector we have the input port and the OCH signal, and in the treatment we have the output port.
Alessio, can I just say something? This is what we used for the OFC demo phase 1.5.
Yeah.
So this code is
ready. Yes, in the next slide we see also the configuration of the line ports.
Exactly. So this code is already there from an ONOS perspective for the Cassini device. This OpenConfig is an agent that Metro Hall has, and for the Nokia transponder that we used, they already have the capability to do this. So accept an optical connectivity intent. And that's what we generate from the TAPI northbound, and that was contributed by Ramon. That optical connectivity intent is also the one that generates the rules for the ROADMs in this case, but the open line system in our target deployment.
Yeah, and we see that the rules of the ROADMs are a bit different because they specify the OCH signal in both the selector and the treatment. If you go to the next slide, we see instead here we have requested from that REST application an intent between two client ports that in this case are port 10106. So in this case, both an optical circuit intent is generated and an optical connectivity intent. And here I used a unidirectional example, but the patch also works with bidirectional intents. And you see that in each transponder, we have a flow rule coming from the optical connectivity intent, that is the same of before, and a flow rule coming from the optical circuit intent. In this case, the optical circuit intent, you see that in the selector as the client port, while as an output port in the treatment as the line port that is the same line port that is used by the optical connectivity intent. Yes, you can go to the next slide where
okay, so
I have
just
listed.
can I intercept for a second? So the idea behind this extension is that we were having the phase 1.0 code, which was doing exactly this. So what this provides is a cross connection between a client side, the 10106 port, and the line side, the 10102 port. That is the same exact scope of the phase 1.0, but now we've done, instead of a CLI command or just a pure TAPI request, is done TAPI, then an intent, which is replicated across ONOS and has the beauty of already having some path computation elements inside it instead of having us to do it. And also it enables us to clean off some of the netCFG based code that was existing from a phase 1.0. That's why I asked Alessio to create a presentation on this, because I wanted to explain exactly the reasoning behind moving also the logical channel assignment, which is done to create this flow rule specifically, to move also the logical channel assignment, the cross connection, to an intent-based approach. Makes sense? Any questions? Okay. If not, Alessio, please go ahead.
Yeah. In these slides, I reported some assumptions that we did essentially on the naming of the components in the OpenConfig model. This because doing these assumptions, the developing of the driver has been simplified. So this is, you can say, the first version with this assumption. Essentially, the first 5 assumptions are on the naming of the several components, the ports, the transceivers, the channels. All of them are named with a prefix, we can say, and an integer that is the same in the sense that, for example, port number 11 has the name port 11, and the transceiver that is associated to port number 11 has the name transceiver 11. And these are the first 5 assumptions, essentially. Then also we are considering now that there is only one assignment per logical channel that has the index 1. This helped me because I essentially did not consider those fields as an array, but as a single field. Obviously, both these assumptions can be removed. We can say we can do a more general version. And what also we have discussed with Andrea is that one possibility is to use the annotations in the ports that are already used for other to store other information. On
that note, I just want to show you an example of that. Basically, the idea is that in the Cassini terminal device discovery, we already do that, meaning that we don't get the elements from the OpenConfig model itself, meaning that the OpenConfig model does not have the ONOS-ODTN augmentation, but instead we kind of calculate what is the client and what is the line side based on a knowledge that the XE11 is the client and the OE1 is the line. So we do that, and if we match the client, we put a client type, we do some computation of the port number in here, and then we create the connection ID based on a specific again computation that we do. So this is something that the developer can pick and decide. Either it's exposed through his agent, or if it's not exposed, as it was not an OpenConfig agent on top of Cassini, what we do is we populate ourselves the details, and those details are the one that Alessio is using.
Yeah, and something similar can be done in this batch, and to remove these assumptions. Here I have reported on the right side of the slide an example just to understand. You see the name of the port, the name, the ONOS index, and then the name of the transceiver, all of them with this policy that I have assumed. Also in the Gerrit patch, you find the XML that we have considered. Yes, Andrea, you can go to the next one, where I have just reported what I know, that is few, is not so much regarding the tributary slot. Essentially, this behavior is already present in ONOS, and it is required to support the multiplexing of optical circuit intents into optical connectivity intents. The idea is that using this behavior, the allocation parameter will be properly configured to the right number, considering that some slot in the OTN hierarchy are already used, maybe from by other connections, and so we have so these instruments that we can use to implement the multiplexing of circuit intents inside connectivity intents. However, this is something to do in the sense that some code is already there, but it has to be tested and see if some work is needed. And then the last slide was just I have just reported, how to say, because I think this is something that can be useful to many of us. Essentially, it is this optical rest application that it was already present in the ONOS repository, but we have extended. So in this in its current state, it can be used to push, get, and delete both optical connectivity intents and optical circuit intents. And if for the optical connectivity intents, you are also allowed to specify which a suggested wavelength, we can say, a suggested optical channel and a suggested path. And we are using this application for our traffic engineering evaluation, but I guess we have pushed it on the distribution because we guess that is something that can be useful in many situations.
Yeah,
and that's
thanks,
all.
Alessio. Thanks, Alessio. So just a minor comment on this one. This is actually the same, this is a different from front end than TAPI, but the back end of intents is actually the same thing. This generates an intent on the REST endpoint of ONOS. In ODTN, since we want the TAPI northbound, we chose to use the TAPI northbound as generator for the intent. But the key component really of this patch is the generation of the capability to support not only the optical connectivity intent, but also the optical circuit intent.
Yeah, essentially, if I can add the detail on how the patch works, since we know that the flow rules of the two types the optical circuit and of the optical connectivity as different fields in the selector and in the treatment. When the flow rule arrive at the driver understand if it is, for example, how to say, for the configuration of the logical channel or for the configuration of the line port, and then push the proper XML to configure, just to enable the line port if it is coming from the connectivity intent, or to do the association between a line port, a client port, and a line port if it is an optical circuit intent.
Okay. Thanks, Alessio. So I encourage everybody to take a look at the patch that Alessio submitted. I think that I'm gonna go ahead and probably merge it pretty soon, and because I want to try this specific file with the Cassini device that we have, because I believe it's just gonna work out of the box. Maybe with some very minor changes based on this prefix channel, which is this assumption that Alessio was making before, which is this dash, port dash, channel dash, and whatnot. But maybe refactoring this a little bit could enable us to use this across every device that we have for testing. So that's kind of the goal, having this unique class to enable flow programmability for all the terminal devices, supporting both client and optical circuit intent and optical connectivity intents. One thing that remains is, again, testing. So I'll work with Alessio to do the testing on these elements. So that's really about it on this patch. Any questions or thoughts? Okay. If not, thanks, Alessio, for the discussion. I'll upload the slides. Or is that okay for you?
Yeah, sure.
Okay, thanks. I'll upload the slides to the ODTN folder and include them in the link, with a link in here. Maybe something that you could do is put together a small workflow example. Okay, I'm sending this command to ONOS. Then I'm sending this command. Sure. And this is kind of what I have as a topology. Just as an example for everybody to understand the workflow.
Okay.
Okay. Thanks.
Okay. Okay. Thank you. I have to go, so I say bye to all.
Okay. Thanks, Alessio. Catch up with you later. Bye bye. Okay. I don't think we have people from TAPI on the call, so I'll just skip the TAPI update and I'll go forward with the Jira stories. So I would like to ask Buyan to comment on the completion of 7883 and 7884. Buyan?
Yeah, I'm here. Can you hear me?
Yes.
All right. About these two pads, yes, we did a lot of works the last week, and until now we have tested the line-side connectivity and client-side connectivity creation, deletion on the single ONOS instance and the multiple ONOS instance. And there is only one question left for Jordan, which is about the parallel questions. And then we leave it for Jordan to solve that. And for all other questions, we have solved it, and we have merged the patch to the ONOS master branch. So we think the testing for the ONOS topology test and the connectivity service test has already done. And in the next step, we will do more things about. Yeah, I just received Andrew's email, and next we will do the STC patch on 2.0 version, and do all the single instance test and the multiple instances test again. Or any comment?
If I may comment on that, Buyan, thanks for that. So basically, what we are capable of doing now is automated testing. So we can bring up ONOS, make sure that it is running, make sure that the ODTN app is deployed, make sure that TAPI northbound is existing, make sure that we are in a state where we then can populate the devices, make sure the devices are there, make sure that the ports are populated into the northbound of TAPI through DCS. Then instantiate a line-to-line connectivity service, make sure it's there. Then a client-to-client, make sure the cross-connection is there, and make sure the flows are properly propagated, and all of that testing is done in a way that it can be automated. Through this automation, we actually found out in the 3-node instance there were some failures, and that's what Buyan was mentioning before about the mismatch within the ports. So that happens probably because of ordering of the reading and writing to DCS when different devices have different ONOS masters. So this is something that we're trying to fix. And that's why I assigned to Buyan 7851 and 7866 that are about really this testing. So what I would also, I forgot to mention it in my email, Buyan. What I would like to ask to you, if possible, is for you to create a wiki page outlining the steps to do this testing. If somebody wants to get the code and get the STC test and make sure that it works on their machine, what are the steps that are needed? So that's, I think, something that if you can, you could create under the ODTN wiki page. That would be good to have in order for us to point people at that and enable them to deploy ODTN, because this through this STC you can deploy a 3-node Docker instance of ODTN and ONOS, and then also do the testing themselves with their devices. Could you do that, Buyan?
Mm-hmm.
Okay, thanks. Thanks for that. Okay. So these are these elements, and as I talked about before, I also asked Buyan to take a look at the power configuration behavior for the transponder line side. I also know that the people from Fujitsu, which I had a call with, are working on the possibility of a GNMI driver for the Onefinity device, which is going to go and have the same exact workflow of our netconf-based drivers, but through GNMI, which is very much forward-looking. So that's something that I appreciate, and I know Calvin Wu from Fujitsu and Suraj Banur from Fujitsu are working on that. So as soon as they have some update, I think we will hear from them. Oh, I see Calvin on the call. Hey, Calvin. Any update on your drivers?
Hi, Andrew. Not much yet.
Okay. But thanks for joining. Much appreciated. Okay, so that was about it for our tasks. Any questions, any comments? Okay. So So the last point I have on the agenda is an update on the next gen configuration. Again, it's probably somebody know that we are working on this next gen configuration subsystem for ONOS. Last week we had a TST meeting on Wednesday where we decided some of the points. We're gonna go probably with a Go-based approach, GNMI on the northbound, GNMI on the southbound, and start with a single device transactionality of the configuration, and then move to a more to more devices in transactionality, meaning that it's an all or nothing on not just one device, but on a set of devices. And we're going to start the work on that probably in the upcoming weeks. We don't yet have a target date for any showcase of it, but I think it's going to come into play within the ODTN project pretty soon. And but I'll just keep everybody up to date as that goes along. It will be public from the get-go on GitHub, and everybody can comment, can do pull requests if they are interested. On the project, it's going to support GNMI, southbound and northbound, but it's going to be a beta until the first release. So it's just that since it's a fairly new framework, fairly new language, microservice-based approach, gRPC, it's all new stuff. The team within ONF and the community will work on a beta version where the APIs are not fixed until we decide that they are with a first release of it, which is not going to happen very soon. It's not going to be in the order of months. I think that the first release might come like in a year from now. But that's kind of the state of the next gen configuration. Any questions? No? Okay. If not, the last point I want to make is that if anybody next week is in the MPLS SDN NFV conference in Paris, I am going to be there, and just come and find me or send me an email and we can arrange a meeting. I'd like to discuss and meet you guys in person. So that's just a advertisement for a meeting together. Next week in the MPLS SDN NFV conference in Paris. I'm gonna try and keep this conference next week. If I can't, for other commitments due to the conference, I'm gonna send an email to everybody and cancel it, but I'll try to keep it. Is anybody gonna be at the show? Okay, maybe not. Whatever. If anybody is, just let me know, and we'll try to catch up over there. Any other comments or questions? Okay. If not, I'll see you guys next week, and we'll catch up over email for anything that is needed. Thanks a lot. Take care. Bye-bye.
Bye, Andrea.